Okay, BMIS 270, Chapter 4, Part 2, and we're taking a look at network topologies and network connectivity, those sorts of things. So, to start with, we'll take a look at network topologies. Now, a topology is the physical layout of the devices in the network. So, in the pictures that we have here, we really have, well, three different kinds of topologies. Because when you refer to a topology, it is, and when we say physical, it refers more to wires rather than wireless. Although wireless is a topology in itself. So we'll start with the star topology, and what we see here is a switch or a hub, and probably a switch at the center of this particular star. And then we have notebooks or PCs that are connected from the hub, or the switch I should say, to each one of the PCs individually. Now, once again, the advantages is this wiring is very inexpensive. Also, there's segmentation going on, so that if this computer has a problem, if this wire has a problem, if you have a child and they start pulling on the cable and break the cable, that only this computer will go down, the rest will continue to run. Let's see, it's easier to fix because you'll know that this computer has a problem, either software, hardware, or cabling, or perhaps a port on the switch. But you'll have a definite idea of where the problem lies. And then one problem doesn't bring the entire network down, so it'll continue to run. However, the disadvantage is that there are more cable runs. So not such a big deal through your house, but if you have 20 computers in a lab, you have to run one single wire from each one of those computers to the switch itself. Now, the other disadvantage, and I should note this, is it's a single point of failure. And I think it's just like the video had said, if this device goes out, then you're just stuck. Your whole network is down. So that's why you typically have a spare. I mean, if you had a bigger business, it would be a spare. For your home, you can go out and buy another one and get up and running pretty quickly. Now, a bus topology, you don't see that a lot anymore. So I'll just be very brief about it. But it was just basically one cable with all these devices hooked onto it. If this cable broke at this point, all the devices in the entire bus would go down. So it was easy to add nodes, though. So you would just add one after another after another. That was really easy to add. Fairly inexpensive. But once again, if you just, one problem brings the entire network down. A mesh topology, this looks like the internet itself. Because you can imagine routers, a router, a router, a router. And the advantage is redundancy. So if this line breaks for whatever reason, there are at least 2 different ways to get information from point A to point B. Okay, and that's the idea behind the internet and routers. Okay, so it's a topology of the internet. A disadvantage is it's expensive, and often you have very fast fiber lines in between the particular nodes themselves. So again, the redundancy is a really, really good thing, but for that redundancy, you have to pay something, and that's the trade-off on that. And of course, wireless, you just have this little box right in the middle, this wireless router in the middle, with a firewall. We've talked about a firewall. Here's your ISP out here, and then you have all these devices access wirelessly. And that's a really great deal. It's really easy. It's a shared medium, which means it's a little bit slower. If this is a 100 megabit wireless connection, and you have one device on, okay, just one device, that device gets the entire bandwidth. But if you have 10 devices on, then that medium, that bandwidth is split up by 10. So it can get slow. It depends upon how many devices you have actually connected to it. The next slide talks about network media. Okay, so you have twisted pair, coax cabling, and fiber optic. And coax cabling, that's really more like your cable company. Let's see, it is 802.14 is the particular standard that's associated with cable. But twisted pair, these are pairs of wires. There are 4 pairs of wires, which means there's 8 wires. They're twisted at different frequencies, and that cancels out radio frequency interference. It's very inexpensive, and typically the wiring that you see within most local area networks. Let's see, used for telephone and network connections, 100 meter cable run, so 300 feet cable runs. If you have to go beyond that, you have to have a router in between there. Cheap to install, and it's typically used on Ethernet, which is a standard called 802.3. Again, the coax cabling, 802.14, and then a fiber optic. Fiber optics are typically your backbone media. So there's a glass or fiber that strands through which the light passes, and so it's completely light dependent. You have LEDs or lasers on each end firing the light. Just like in wire, you have electronic ones and zeros. There's either a signal or there's no signal, and it's all based upon timing. In fiber, there's either light or no light based upon timing. And then so a signal may be composed of a sequence of light signals. And it's fired again by an LED or a laser. Let's see, high-speed communication, so it's very fast. Let's see. The other thing, you can read whatever it says here. But the other thing is that there's no RF interference. This is light, and that there is no RF interference. So, as an example, if you ran UTP through a lab where you had CNC machines, a whole bunch of lathes, all kinds of different industrial sorts of machines, you may get some interference, and that may impact or mess up your signal. Okay? Now, the fiber, it's more expensive, but you don't have that interference. So there are some places, even in a local area network, that would make more sense to run fiber. Okay, now, communications protocol and network standards. So a protocol is a set of rules of communication. It determines how devices on the network communicate. So 802.3 communicates in a certain way. It's called CSMACD, carrier sensing, multiple access collision detection. It works in a certain way, and that's what that protocol is. Now, a standard is a set of criteria or requirements approved by a recognized standards organization. Network standards address how network computers connect and communicate, and they're needed to ensure products can work with other products. So printers have to work a certain way, PCs have to work a certain way, routers and switches all have to work a certain way if they're all working on Ethernet. And again, Ethernet is an 802.3 standard. Your wireless LANs are 802.11, but you have A, B, G, and N. And you typically see G and typically N anymore. N, B, G, and N are compatible. A is just sort of out there. I hear there's another protocol coming along, and of course if I use this next year, this conversation will be dated a little bit, but it's A-like. So whether it's A compatible or not, I don't know, and I'm not even sure. I think it's called AC, I believe. And 802.14 are cable modems. Now, in a communications protocol is a set of rules that determine how devices on the network communicate. So I'm using protocol and communications protocol synonymously. Now I have about an 8-minute video that I'm going to go ahead and run here for from CompTIA Network. It talks about all these things in sort of a nutshell. So I'm going to go ahead and run from the current slide. I think we'll be able to see that okay. I need to mute this, go back to there.
The star topology is by far the most common topology that is used today. In this setup, all computers are connected to a central wiring point, such as a hub or a switch. Data passes through this central point before continuing to its destination. One of the major benefits of this topology is that if one computer failed, or if there was a break in a cable, the other computers will not be affected because each computer has their own cable connection. However, a disadvantage of a star topology is that if the central hub or switch fails, then all the computers on that central point would be affected. This is called a single point of failure. If this happens, the entire network goes down. This is called the bus topology. The bus topology is pretty old technology, and it is not used today that much. This is the kind of network setup where each of the computers and network devices are connected to a single cable or backbone. This backbone is a coaxial cable. The computers connect to this cable using special connectors called B and C, or also known as T connectors. One of the advantages of the bus topology is that it is fairly cheap and easy to implement. The disadvantage would be is that it requires that the cable be terminated at both ends using terminators. In order for this setup to remain operational, there must not be any open connections, including the ends that attach to the computers. If a computer is removed or added, or if the terminators are loose or missing, then the cable will be open and data would bounce back. This is known as signal reflection. If this happens, data flow would be disrupted. This is called the ring topology. A ring topology is a type of network configuration where each computer is connected to each other in the shape of a closed loop or ring. So every computer on this network has exactly two neighbors for communication purposes. Each data packet is sent around the ring until it reaches its final destination. This kind of topology is rarely used today. The advantage of a ring topology is that they are easy to install and easy to troubleshoot. However, the disadvantage would be that if just one of these computers goes down, or if there was a single break in the cable, then all data flow would be disrupted. 802.3 is Ethernet. Now, Ethernet is by far the most common technology that is used today. In fact, Ethernet is the technology that is used on the Internet. Ethernet uses an access method called CSMACD, which stands for Carrier Sense Multiple Access with Collision Detection. We'll go into more detail about this later on. The speed of Ethernet ranges from 10 megabits to 10,000 megabits. It uses both copper wire and fiber optic media. Most commonly, Ethernet uses the star topology. Token ring is the 802.5 standard. Token ring was a technology that was developed by IBM in the early 1980s. This technology became pretty popular because it virtually eliminated all collisions by its unique token passing access method. This is how it works. Computers on a token ring are arranged in a physical star topology in a logical ring. In the center you have a special hub called a multiple station access unit. In this hub there is an electronic signal that is constantly circulating around the ring. This token must be attached to every message on the network if the computers want to communicate with each other. Let's go ahead and demonstrate this. The first computer will go ahead and send its data. The token then will come around and attach itself to that message, and then it takes it to the appropriate destination. So you can clearly see why this eliminates all collisions and why it became so popular. The RJ45 is the most common network connector. This is an 8-wire connector used to connect computers to local area networks. Like the RJ11, it also locks itself into place by a hinged locking tab, and it also resembles the RJ11 but it's larger. This connector is called the F-type. The F-type is a threaded connector typically used on coaxial cables. These are used primarily by cable providers to attach to cable modems, and a hand tightens by an attached nut. This is the USB connector. The USB is very common on desktops and laptops. Many manufacturers make wireless network cards that plug into a USB port. The USB has two different connector types. Type A and Type B. The ST or straight tip is also a fiber optic connector. This uses a half-twist bayonet type of lock. The ST connector is commonly used with single-mode fiber optic cable. This is the IEEE 1394 connector, commonly known as FireWire. FireWire is commonly recognized by its D shape. This type of connection is becoming more popular on desktops and laptops, and is commonly associated with attaching peripheral devices, such as digital cameras and printers, rather than being used as a network connection. These are also found on many types of video and multimedia devices. This is the coaxial cable. This is used today primarily by cable providers to provide computers with broadband internet connection. Early on, it was used as the backbone for networks, such as a bus network. Unshielded twisted pair is the most common type of cable that is used today. It consists of 4 pairs of unshielded wires twisted around each other. The wires are twisted to prevent electromagnetic interference or crosstalk. This type of cabling is mainly used on local area networks. Shielded twisted pair is very similar to unshielded twisted pair, except that it has a foil shield that covers the wires. This shielding adds a layer of protection against electromagnetic interference leaking into or out of the cable. A hub is a device that has multiple ports that accepts Ethernet connections from network devices. A hub is not considered to be intelligent because it does not filter any data or has any intelligence as to where data is supposed to be sent. When a data packet arrives at one of the ports, it is copied to all other ports, so all the devices on that hub sees the data packet. There are 2 different types of hubs, passive and active. A passive hub does not require any power, but an active hub does require power.
Okay, so trying to figure out where I am. Okay, there I am right there. Going back to this, so to recap, basically what we've talked about with part 2 is network topologies. We talked about star, bus, and the mesh, and the video really talked about that in more detail. Although the advantages and disadvantages flashed up off the screen very quickly, you can pause the video. Talked about network media. The video talked about that a little bit as well. Talked about some of the standards, 802.3 and 802.11, for instance, or 802.3 anyway, and 5. And so that covers this particular section. Thank you.